Okay, this is part 2 of section 3.3. Now we're into step 3, explore the data. So now you should have your class's data, which means that every class is going to have different answers for this worksheet because every class will have slightly different data. So you're going to need to use the descriptive statistics applet, which has a link in the footnote of your worksheet. You can also find it on Canvas, clicking on applets. That'll take you there. And then descriptive statistics is right there. Click on that. Okay. To do this, press clear data. So we want to clear the data. Okay. And then copy and paste your class data with a one-word variable name into the sample data box. So you don't even have to copy and paste. If you wanted to, you could just like enter it in, like sleep, 4, 5, 6, whatever. I have some sample data that I'm going to work with for this video, which is right here. So I'm going to copy this number, put it in here, Control C, and then Control V. And then I am going to use I think I don't want that. Oh dear. Now I got to do Control A, Control V, use data. Okay. Now, so I use data. So then number 10, summarize the shape, center, and mean. Shape, center, mean with appropriate symbol and measurement units, and variability, standard deviation of the appropriate symbol and measurement units for the sample of sleep times for your class. So over here, I've got this data right here. And so I want the mean and the standard deviation. And so right there, the mean is that, the standard deviation is that, but I don't want you to use the word or the abbreviation. I want you to use the symbols that we learned in our textbook. Okay? So your answers will be different from mine because of your class is different from mine. But that's the way to do it. Okay, so we would say that. Number 11, do these data provide any preliminary evidence that students at your school tend to sleep less than 8 hours? Well, that's a question that's going to be different depending on your sample, but looking at the mean and looking how many standard deviations 8 is away from it is a good indicator of like a good guess at this point. So we're going to get, by the end of this worksheet, we'll have a much better, more precise way. But this is, for number 11, give a good guess and use words like, based on the mean. Okay, making an educated guess. So number 12, suppose we've taken many, many samples of the same size from the population of your school. If the null hypothesis is true, so meaning the null hypothesis is true would mean that on average, their students are sleeping 8 hours a night at Grace, but might be a lot of variation, but on average it's 8 hours a night. So if the null hypothesis is true, how do you predict the distribution of sample means will behave? Well, this is a case where, so for number 12, you want to say something about where you think if you took a whole bunch of samples and the null hypothesis is true, where would that distribution be centered, and how would it look compared to our sample? So would it be narrower or wider than our sample, or about the same? And then yeah, that's the main idea. Okay, moving on to 13. Let's read this paragraph before 13. To evaluate the strength of evidence that your sample data provide against the null hypothesis, we need to investigate how often a sample mean as small as the one observed in your sample would occur. If you were selecting a random sample from a population in which the mean sleep time really is 8 hours, in essence, we will apply the 3S strategy as we've done before. A previous section showed that the sample mean should fall within 2 standard deviations of the population mean. Let's now look at using the sample standard deviation instead of sigma. So, in this case, we don't know sigma. Sigma is the Greek letter for the population standard deviation that we don't know. So we'll use S instead. calculate and interpret the equation for the standard deviation. Okay, so here, that means we're going to use that equation from earlier. So the standard deviation of the sample is given further up. Well, actually, not here, but maybe in the book. So the formula for standard deviation was given, well, basically the denominator right there, s over square root of n. Okay, so that's important. Use that. Your numbers will be different from the ones I have here. Okay, all right, so 14. Based on your answer to number 13, does it seem surprising to get a sample mean like the one in your class survey if the population mean is 8? Justify your answer. By surprising, you should be using that 2 standard deviations argument. Are you within 2 standard deviations of 8 or not within 2 standard deviations of 8? And not population standard deviations like sample standard deviations. For instance, sample standard deviations, that denominator right there. Okay, we're going to calculate the standardized statistic based on the observed data by computing that. So, now, by the way, mu0 or mu0 is the number that goes with the null hypothesis. Okay, so now we're going to open up the one mean applet. So go back to our applets page, click on one mean. Okay, and notice that 1 has been selected. That's good. Okay, so this is a hypothetical one right here. Okay. And a histogram displays this population distribution. For now, we are assuming the population distribution is normally distributed with mean very close to 8 hours, standard deviation about 1.5. Okay, so check the show sampling options. So stay with this data, not our data for right now. Show sampling options. Set the number of samples to 1,000. So number of samples to 1,000. And then the sample size to our sample size. So my sample size is basically 22. So I'm going to use 22. But your class might be different size. Okay. And then press draw samples. So let me scoot over. Oh dear. Oh, not good. Keep that back at where it was. Okay. So here we are. So the mean, that looks about right. Okay. So if I change this, does that change there? Yeah, it does. I need to make sure I get that back all the way to 0 perfectly, or pretty close. There we go. You can use the arrows to get it perfectly. All right. There we go. So, otherwise, these numbers would have been, the mean would have been a little bit off, which would have been not good. So, in number 15, is the distribution of sample means centered around 8? Is the distribution approximately normal? Is the standard deviation close to sigma over square root of n? Show your calculations. So, in my case, it's 7.989 is practically 8. The standard deviation is 0.317. So if we have a calculator, let me move that to right there. And so we can take if I calculate my standard deviation here, which was 1.5. Let's see, I might need to. Okay, so 1.5 divided by my sample size is 22. Then take the square root of that denominator, and I get 0.32 basically. And if I look over here, my standard deviation is basically like my standard deviation here is 0.3198, and over here is 0.317. So basically the same. And then is it approximately normal? You can look at that as like, is it fit the bell curve? Mine is yes. So mention that. Okay. And then, so now pay attention to the directions. So above the distribution of sample mean, select the radio button for T statistic. Okay, T statistic. So then if you check the overlay T distribution, overlay T distribution is down there. You should see that the T statistic are well modeled by something called the T distribution. So look how the T distribution is the perfect mathematical thing, and the histogram is my simulated data, and it's pretty close. Okay. But if we instead check the overlay normal distribution, there's not much difference in the two distributions. So here, if I overlay the normal distribution, then notice how it's a slight change, but hardly anything. Because once you get to about 22, they become very, very close. Okay, so use the applet, the T statistic you calculated for your, use the applet, the T statistic you calculated for your class survey, and the count samples box to estimate a p-value using the T distribution. So T distribution, count samples, and so we're going to count 8. We'll count that. So our count of sample statistics that are 8 is 0 out of 1,000, and our theory-based p-value is also 0. Okay, so that's, you give the value, number 17, based on the p-value. Do your sample data provide strong evidence that the population mean sleep time at your school last night was less than 8 hours? Justify your answer, as if to a friend who's not studied. Okay, statistics, missing word down there. All right. So in this case, do that. All right, I'm gonna stop here and we'll start the next video.